Hello everyone. Today let's consider equations of motion under gravity. What is motion under gravity? That is when an object is moving either vertically upward or vertically downward under the influence of gravity. And in the absence of air resistance, all objects force freely towards the center of Earth with constant acceleration, which is acceleration due to gravity. And the value of this acceleration due to gravity on Earth is approximately 10 meter per second square. In this video, we are going to be using this value because it's an approximate value, though it's not the same everywhere. But for the sake of what we are discussing in this video, we are going to stick to this value, which is 10 meter per second square. And no matter how big or small the body is, as long as the air resistance is absent, we believe that all objects falls with this acceleration, which makes the motion under gravity, the motion of an object under gravity, a uniformly accelerated motion. So therefore, we can apply all the equations of uniformly accelerated motion derived in our last video in solving any problem related to motion of an object under gravity by changing our horizontal distance s to vertical distance h, and by also changing our horizontal acceleration to acceleration due to gravity g. Let's quickly consider the diagram that we have on the screen here. In this diagram shows the path of an object that is projected vertically upward and allows to also fall back to the projection plane. Now, this part represents the path taken by the object while moving up, while this part represents the path taken by the object while coming down. Okay. Now, what this diagram is explaining is that at this point, the object has attained its maximum height that it could get to before coming down. Now, at that point, we have a final velocity to be equal to zero, because for the object to get to this point and before coming down, the object will stop for maybe a microseconds or milliseconds before falling back to the earth. So that is why the final velocity at that point equals to um, zero, no matter the velocity the object has been moving with. And another way to look at this is that when object is thrown vertically upward, the velocity will start reducing until it gets to zero. That is, the object will be decelerating until it gets to uh, zero velocity, while the object will fall back to the earth. And when the object is falling back to the earth, or objects drop from a given height, we have the initial velocity of such objects to be equal to zero. And this represents the projection plane, or where the object will land. Okay, now what can we deduce from this diagram? It means we can say when the object is moving vertically upward, the object is decelerating uniformly, because the velocity is reducing until it gets to zero here. And also we can say when the object is dropped from a given height, or when the object is falling back to a projection plane, it accelerates downward. That's another thing we can pick from this diagram. Okay, now let's move to the equation of motion under gravity. Remember, we derived 4 equations in our previous video, but we are using just 3 here. The reason is because the fourth one does not have acceleration as parameters. Okay, now here we concluded that for object moving vertically upward, we have for this equation. Remember, in our previous video, we have v equal to u plus at. Well, this time around, our a has changed to g. And why do we have a negative in this equation? The reason why we have negative in all this equation is because we believe that okay, let me say, for the sake of this video, because any part can be chosen as a negative or positive. Let's say like this, we may choose this up part as positive, or we may choose this down part as negative. That is, when an object is moving up, we can consider the parameters to be positive, or we can as well consider it to be negative. But what we are going to stick to in this video is the fact that we are able to establish with the diagram that we have here, that when the object is moving upward, the object is decelerating, and when the object is falling back to the earth, the object is accelerating. And remember, deceleration is negative acceleration. So that is the fact we are going to stick to. That is, we want to establish a fact on the want to establish a point on the fact that when object is moving upward, it has a negative acceleration, and that is what we have in this equation here. And when object is moving vertically downward, it has a positive acceleration. So let's quickly consider how to use this one in solving some of our problems. Okay, now we have some facts here. The one we've not really talked about is the third one here, which says when a body returns to the ground or a reference projection plane, the height will be equal to 0. Every other one we've spoken about them in the diagram above. Okay, we are going to see this in one of our example, this third one, and we are going to emphasize further on that. Okay, now let's go to our examples. Our first example is a ball is released from a height of 40 meters above the ground. We have to find its velocity after 2 seconds and its velocity on hitting the ground. So we have two velocities in this case. Now the first one we have to calculate is velocity after 2 seconds that the ball has been released from the height 40 meters. Now what is the meaning of this velocity? As long as the journey still continue, we refer to this velocity as instantaneous velocity. And with this, from what we discussed in the diagram that we just look at above, we discover that when object is dropped from a given height, the initial velocity u will be equal to 0 at point of release O, and the velocity after 2 seconds can be calculated using this formula, though in some text you are going to see this formula as v equal to gt. So what they are telling us is that they made u equal to 0 already. Okay, in doing this, we can substitute the values given here into this equation, and we arrive at this, and this will give us the instantaneous velocity as 20 meters per second. Okay, now the second part of the question says on hitting the ground, that is the velocity of the body on hitting the ground. In as much as we don't know the time the body will hit the ground, so we are going to choose an equation that does not have time as one of its parameter. And choosing this, in some we will still consider our initial velocity to be equal to 0. In some textbook, you are going to come across this equation as v equal to square root of 2gh, because our u is equal to 0. That is what will make the equation to become this. Okay, now but substituting the parameters into this above equation here, we have what we have here, that is our v square will be equal to 800, and to find the value of our v, we need to look for the square root of 800, and square root of 800 equal to 28.3 meter per seconds. Okay, moving away from that particular question, let's consider example 2. In our example 2, we have to calculate the maximum height reached and the total time spent in air by a ball thrown vertically upward from the ground with an initial velocity of 20 meters per second. The maximum height reached and the total time spent in air by an object thrown vertically upward from the ground with an initial velocity 20 meters per second. Here we have our u to be equal to 20 meters per second. Okay, our u equal to 20 meters per second, and we know we've discussed earlier in this video that when object is projected vertically upward at the maximum height, our final velocity will be equal to 0. That's another parameter that is hidden in that question. And okay, and when an object is thrown vertically upward, we believe, according to what we've discussed earlier in this video, that the object is decelerating. as the object is moving upward. Okay, now putting all these facts together, we pick this equation to solve our problem. Okay, now since our final velocity will be equal to 0, we made the necessary substitutions into this equation, and we have this. Our 20 square will give us 400, and taking this part of the equation to this side, that's why we have a 20h, and making h the subject of the formula, we have the value of our h to be equal to 400 divided by 20, which is 20 meters. So the maximum height reached by the object, projected with initial velocity of 20 meters per second, is 20 meters. Okay, the second question asks us to calculate total time spent in air. When we say total time spent in air, it means total time for the object to move from projection plane to the maximum height and come back to the projection plane. So that is total time spent in here by the object. And if this is the path taken by the object up and down, okay, we can calculate the total time spent in air by the object, either by saying by the time the object will have come back to the projection plane, h will be equal to 0, and we can use this equation here when our h equal to 0, okay, to find our time. And in doing that, we are going to have this. We're going to have this, substituting all the value into this equation here, because by the time the object is coming back to the projection plane, we have h to be equal to 0, and definitely we are going to have our initial velocity to be 20. We are looking for t, and our acceleration due to gravity as 10. Okay, substituting all this into this equation, we arrive at 20 t equal to 5t squared. Taking t away from both sides, we have t equal to 20 divided by 5, and our time will be equal to 4 seconds. That is the time taken for the object to move vertically upward and come back to the projection plane, equal to 4 seconds. Okay, there's another way to this. We can approach this using another method. We can as well calculate the time taken for the object to get to the maximum height here. At maximum height, our v will be equal to 0. So finding the time to get to the maximum height, we have 2 seconds. And the time taken to reach the maximum height is equal to the time to reach the ground again. That is time taken to move from here to this point equals to time taken to move from here back to this point. So that is why we multiply these two. We multiply the value gotten here by 2 here, and we still arrive at 4 seconds for that equation. So you can choose to use either this or this. Okay, and don't forget our acceleration due to gravity, that is g, is always 10 meters per second square. Either it is given or not in this video, that is the value that we use, or true. Okay, let's consider the last example in this video. Example 3. In our example 3, we are to calculate the time taken for the stone drop from the top of a building 90 meters high to reach the ground. The time taken for the stone drop from the top of a building 90 meters high, that is the height of the building is 90 meters, to reach the ground. Don't forget our g will be equal to 10 meters per second square. And for an object drop from a given height, our u will be equal to 0 meter per second. And when we consider this from equation h equal to ut plus half gt squared, because our object is falling down, we use plus. So if u equal to 0, the equation turns to gt squared over 2, and this is what you're going to come across in some of our textbooks. So that is what is here. So substituting the values of the parameters in the equation into this equation, we have this, making t squared the subject of the formula. We arrive at this, that is how we cross multiply 2 times 90 will give us 180, and making t squared the result of the formula, we have 180 over 10, and that will give us 18, and our t will be equal to square root of 18, which is equal to 3 root 2 seconds. So the time taken to fall from height 90 meter to the ground is 3 root 2 square. With that, we come to the end of this video, but just before we go, I would like to introduce to us again this physics practical book. The name is Refined Physics Practical Book. The book is very good and it's one of the best you can see around. The reason why this book is one of the best is because the book has the practical exercises for our school candidate, that is our WAEC and NECO candidate. And in addition to that, the book also has practice exercises for private candidate, that is the candidate writing GC and NECO GC. And I'm referring to alternative to practical in physics, and also practical exercises for candidate preparing for Cambridge IGCSE physics examination. Everything is in this book, and the book is Teach Yourself fashion. In this book, you'll be taught how to present your table in practical, how to record your observation on the table to a given degree of accuracy, how to plot your graphs, how to find your intercept, your slope, how to write your precaution, and how to write your conclusion. Everything is given in this book, and it's a teach yourself fashion. As a teacher, you can recommend this for your school, or as a student, please, you can also contact us to get a copy. And to get a copy of this book, you can contact any of the numbers shown on the screen or the email address. Or if you choose to go for a soft copy of this book, it's available on Amazon. You can get the soft copy of the book on Amazon. Click logging on to the Amazon using that link. Also, we have some other services that we render. Reform Physics Tutor Virtual Teaching Platform is a platform for free. It's a platform for online physics and mathematics tutorial for examinations such as WAEC, NECO, UTME, Cambridge IGCSE, and some others. So if you are interested in our online classes, you can as well reach out to us using the contact on the screen. And for all what we've discussed so far in this video and some of our other videos, we've compiled an ebook for it. In case you're a student that you need e-note, we compile this, and you can just also reach out to us using any of these on any of the numbers that has been displayed on the screen, and we'll discuss. We can get a soft copy of this note across to you, and it will be very, very useful for you. And just before I close this chapter, please, if you are yet to subscribe to this channel, please do. And so that when we release a subsequent video, you get notified, and also to help these channels to continue running. Whenever you feel like maybe this video is adding any value to you, please always give us thumbs up, and also comment. Just leave your comment on the comment section. And if you still have any question on any of our videos, the comment section will be open for your questions, and the question will be attended to. Thanks for watching.